Today we are going to review scientific notation. Please copy down the standard benchmark indicator on a clean page on your math notebook. The student will investigate and describe the concept of scientific notation. Scientific notation. Scientific notation is an easier way to write very large and very small numbers. A number in scientific notation is written as the product of a number between 1 and 10 and a power of 10. You write the power of 10 using exponents with 10 as the base and the number of times 10 is a factor as the exponent. Example 1. Write 4.2 times 10 to the 7th in standard form. The power of 10 tells you how many places to move the decimal point. Move the decimal point to the right 7 places. Right, and the really important thing to remember here is that it's moving the decimal point. It's not the number of zeros you add. Right, so if we look over at the example, they move the decimal point 1 place behind the 2, then they have to move it 6 more places to get all 7. That means we're only adding 6 zeros here. So 4.2 times 10 to the 7th becomes 42 million. Try it. Write 6.12 times 10 to the 9th in standard form. How many places to the right will the decimal point move? And we know the exponent is 9, so that tells us how many places to move the decimal. Then we're going to look at our number down below. We need to move the decimal 2 places to get it past the 12. And then we're going to have to go 7 more to get it to the full 9 places. So we're going to write 612 followed by 7 zeros. So we get 6,120,000,000. And we can check to make sure our answer is right by going back and counting to make sure we have 9 places from where the decimal started to the end of the number. For C, we have 5.6 times 10 to the 7th. So we know we're going to move the decimal point 7 times because that's what the exponent tells us. We know it has to move once to get around the 6, so we're going to add 6 zeros after that to get all 7 places. Then for D, we have 1.82 times 10 to the 6th. So we know we need to move the decimal 2 places to get it past the 8 and the 2. And then we need to go 4 more places to get the full 6. So we're going to add 4 zeros on the end of this. So we get 1,820,000. Example 2. Write 7,089,000 in scientific notation. Write 7,089,000 as the product of 2 numbers. The first factor is the decimal number with 1 digit before the decimal. To write this number, move the decimal point to the left 6 places. The second factor is a power of 10. The exponent is the number of places the decimal point was moved. So we know every whole number has an invisible decimal behind it. So we're going to take it from the end of that number all the way up to where the 7 is. So our first factor becomes 7.089. And you have to write the first factor out until all you have left is zeros after it, times 10 to a power. In this case, it's 6, because the decimal had to move 6 places. Try it. Write 908,000 in scientific notation. How many places to the left will the decimal point move? Well, we know it needs to come from the end of the number to just behind the first digit, which is the 9, so it needs to move 5 places. Then our first factor is going to be 9.08 because we have to have all of that number until there's just zeros left after it. The second factor, we know the base is always 10, and then we have to check how many places did the decimal move. It was 5, so the second factor will be 10 to the 5th. Then we're going to write it out as a multiplication problem, 9.08 times 10 to the 5th. Write each number in scientific notation. So starting with I, first thing we need to do is write the first factor. So it's going to be 4.23 because the decimal always goes after the first digit. And we know it's always times, so our multiplication symbol, and then we have a base of 10. And in this case, the decimal had to come from the end of the number to right behind the 4, so it came up 8 places. So that's going to be our exponent. For J, we're going to bring the decimal up to right after the first digit, which is the 5. So we're going to have 5.06. So we have to keep all the numbers until there's just zeros at the end. Then we're going to count how many places we had to move the decimal to get it right behind the 5. And from the end of the number to the 5, there are 7 places. So our answer is 5.06 times 10 to the 7th. For K, we know our first factor is going to be 1.2. Times 10 to the 5th in this case, because we had to bring the decimal from the end of the number to right behind the 1. So we get 1.2 times 10 to the 5th. Finally, for L, we have 90 billion 60 million. So our first factor is going to be 9.006. Then our exponent is going to be how many places the decimal had to move to come up to behind the 9. In this case, it had to go 10 places. So we have 10 to the 10th. So our answer is 9.006 times 10 to the 10th.